All right, welcome to a brand new series I'm calling Explaining Household Stuff. And for our very first one, we're diving into this new exhaust fan I just got for the kitchen. Now, it looks pretty simple, right? But trust me, there's a ton of cool science packed into this thing. Let's figure it all out.
Okay, so check this out. This is the Tornado 6. And yeah, it's a fan, but it's way more than that. It's basically a high-powered machine for keeping the air in our kitchen from getting all gross and smoky. But the coolest part? It comes with a secret language, a kind of code that tells us everything it's capable of.
And here it is. See the sticker? To most people, it's just a bunch of boring letters and numbers. But it's actually a cheat sheet. It tells you everything this machine can do. So today, we're going to be detectives. We're going to crack this code. First things first, let's tackle all these electrical terms. This is the stuff that actually brings the fan to life. Okay, first up, you see that V? That stands for voltage. The easiest way to think about it is like water in a hose. Voltage is the pressure that's pushing the electricity through the wires. This fan needs 220 volts, which is a pretty standard amount of electrical push in a lot of homes. If you give it too little, it'll be sluggish. Too much, and poof, you could fry it. Next, we've got frequency, measured in hertz, or Hz. So if voltage is the pressure, you can think of frequency as the rhythm or the heartbeat of the electricity. Our fan here runs on 50 hertz, which literally means the electrical current flips its direction back and forth 50 times every single second. Getting this right is super important, because if the rhythm is off, the motor can spin way too fast or too slow and just burn itself out. And the last of the electrical trio is power, which we measure in watts. This is basically the fan's appetite, how much electricity it gobbles up every second it's running. This one uses 40 watts. To give you an idea, that's about the same as a small light bulb, which is awesome. It means it's really energy efficient. Okay, so we've got the electrical stuff down. Now let's get to the really exciting part. What can this fan actually do? This is all about its raw performance. This number right here, this is the one. Volume 780 cubic meters per hour. Forget everything else for a second. This one spec tells you almost everything you need to know about the fan's real strength. So, what on earth does that mean? It means this fan is so powerful, it can move a whopping 780 cubic meters of air in just 1 hour. Try to picture a giant invisible cube that's nearly 30 feet tall, 30 feet wide, and 30 feet deep. This fan could suck all the air out of that massive space in 60 minutes. We're talking about a serious amount of air. Now, cubic meters per hour is kind of clunky, right? So to make it easier for us, we can translate that number. 780 cubic meters per hour is the exact same as 459 cubic feet per minute, or CFM. CFM is the standard way we measure fan power, and that number, 459, is the key to our next big question. So, we know our fan has a power rating of 459 CFM. That definitely sounds like a big number, but is it actually big enough for our kitchen? Let's find out. And this is the ultimate test, right? It's great that the fan is powerful, but is it the right amount of power for this specific room? The answer totally depends on how big the kitchen is. And you can figure this out with some super simple math. It's just 3 steps. First, you just measure the length and width of the kitchen. Second, you multiply those numbers by the height of the ceiling. That gives you the room's total volume in cubic feet. And finally, you use that volume to figure out the perfect CFM. Here's the magic formula. For a kitchen, the general rule is you want a fan that can replace all of the air in the room every 4 minutes, or 15 times an hour. So you just take your kitchen's total volume and divide it by 4. If our fan's 459 CFM is higher than that number, we're golden. It's more than strong enough. So, why even bother with all the math? Well, it's simple. Having the right fan gets all that smoke and cooking smell out of here fast. It just makes the kitchen a much cleaner, fresher space. You could even say it makes for a more inviting room for everybody. All right, we're in the home stretch. Just one last number to crack on this label. A powerful fan is awesome, but we don't exactly want it to sound like a jet engine is taking off in our kitchen. So, how loud is this thing? The label tells us the noise level is 58 decibels written as dBA, but a number like 58 doesn't really mean much by itself, does it? So let's put it in perspective. So how loud is 58 decibels? Well, think about a super quiet library. That's about 40 decibels. Now think about 2 people just having a normal chat. That's right around 60 decibels. Our fan, at 58, slots right in between those 2.
It means, yeah, you'll hear it working, for sure, but it's not going to be so loud that you have to yell over it.
And just like that, the code is cracked. This isn't just a random fan anymore, is it? It's a precisely engineered machine. And now we know exactly what every single one of those numbers means and what this thing is capable of.
So let's do a quick recap. We know it runs on standard power and sips electricity. We know it's a beast with 459 CFM of air-moving power. We know it makes about as much noise as a normal conversation. And, as a little bonus, the label tells us it's built tough, with a pure copper motor inside a solid metal case.
So the next time you see one of these labels on an appliance in your house, don't just walk past it. It's telling you a whole story about what it does and how it works. It really makes you wonder, what other secrets are hiding in plain sight on the gadgets you use every single day?